All right, this is Unit 4, Section 1, Day 6. We are going to continue with adding and subtracting rational functions. So we are still looking at some that don't have the same denominator, but have to now be factored. So if I'm looking at this first one, I'm going to look at the one that actually gets a GCF factored out. So I have 3x squared plus 3x. So both of them have a 3x in it. Oh, let's try that again. So if I divide 3x squared by 3x, I'm left with x, and then plus 3x over 3x is 1. So 9x squared, I'm looking to have something in common. So 9x squared, 9 can be written as 3 times 3, and x squared can be written as x times x. So we do, in fact, have a 3x in this problem and a 3x in this problem. So I'm left with 3x extra here, which is what I'll multiply this by, and x plus 1 extra here, which is what I'll multiply this by. So now 7 times x plus 1 will equal, not equal, I'm getting ahead of myself here, plus x times 3x will all go over the one in common, 3x, times this side, which was 3x, times this side, which was x plus 1. So simplifying the top, we have 7x plus 7 plus 3x squared. And simplifying the denominator, 3x times 3x is 9x squared times x plus 1. And the last thing to do would just be to write it in standard form, right? We like to keep things in standard form. 3x squared plus 7x plus 7 over 9x squared times x plus 1. All right, if I was able to factor the top, I would try to see if there was anything to cancel out. But 3 times 7 is 21. Nothing's going to multiply the 21 that adds to 7. So that doesn't factor any further, and I'm done. All right, we'll do another one together. So again, I'm going to focus on this side first. 9x squared minus 12, there's 3 in common here. So if I take out the 3, I'm left with 3x squared minus 4. And this is just 3 times x squared. So they have the 3 in common. And then this side had an x squared. So this fraction will be multiplied by x squared. And this side had 3x squared minus 4. So this will be multiplied by 3x squared minus 4. So we're going to do 1 times 3x squared minus 4 minus x times x squared all over the thing in common, which was 3 times x squared times 3x squared minus 4. So on top, distribute 1, it doesn't change, and this is minus x to the third over 3x squared times 3x squared minus 4. And now again, let's write this in standard form. Negative x cubed plus 3x squared minus 4 all over my denominator. Okay. So you guys try these two, pause it, and I will show the answers. All right, so for number 1, the denominator factored to 2 times 5x times x. The second denominator to 5x times x minus 1, so they had 5x in common. So the first fraction got multiplied by the x minus 1, the second by the 2x. All right, and we end up with 2x squared plus 15x minus 15 all over 10x squared times x minus 1. For number 2, the first denominator factored to 6 times 2x to the third, the second to 6 times x squared plus 3. So they had 6 in common. The first fraction got multiplied by x squared plus 3, the second by 2x to the third. And we end up with negative 3x to the third plus 3x squared plus 3x plus 9. So notice all of these terms are divisible by 3. And on the bottom, the 12 is divisible by 3. So what I would do is I could really factor out a 3 from up top. And now I'm left with negative x to the third plus x squared plus x plus 3, right? Divide all of that by 3. And now if I divide the bottom by 3 as well, I get 4x cubed times x squared plus 3. And that would be my absolute final answer. All right. For now, I probably wouldn't dock you too much for leaving it like this, because at least you added correctly or subtracted correctly, found the correct terms. But if you notice that it can be reduced, I'd like you to try to reduce it a little further. All right, let's keep going. Now I have a little bit more factoring to do. So in A, 2x minus 2, there's a 2 that comes out, and I'm left with x minus 1. In x squared minus 4x plus 3, right, we're looking for what multiplies to 3 and adds to negative 4, is x minus 3, x minus 1. So again, I'm looking for what they have in common, and they both had x minus 1. Which means the 2 is going to get multiplied on this side, and the x minus 3 is going to get multiplied on this side. So here, we're going to have x minus 3 times x plus 2 minus 2 times negative 2x minus 1. And the entire bottom is going to be the part that was in common, which was x minus 1, times the other two pieces. So times 2 and times x minus 3. So we're going to make sure we distribute here. So we're going to get x squared plus 2x minus 3x minus 6. And then we're going to distribute the negative 2 here. So that's plus 4x plus 2. And then these, I'm just going to rewrite the order, but I'm not going to actually multiply anything. I'm going to put the 2 in front, and then x minus 1, x minus 3. So now I'm going to combine like terms up here. Let me change the way my page looks. That work? Nope, I want entire swing. Nope, I was right. There we go. All right, so the top, if I combine like terms, I only have 1x squared. 2x minus 3x is negative x. Negative x plus 4x is 3x. And then negative 6 plus 2 is minus 4. So this is a nice simple quadratic up here that actually is factorable. So I'm going to factor it to see if anything cancels. I'm looking for what multiplies to negative 4 and adds to positive 3. So that's going to be x plus 4, x minus 1 on top. And the bottom, I'm going to have 2 times x minus 1 times x minus 3. So what's going to happen here is our x minus 1s are going to cancel, right? I mean, just like we did in the lesson in 7.3, if there's something on the top and something in the bottom that exactly matches, they cancel out. So my final answer would be x plus 4 over 2 times x minus 3. And we just want to remember now, because I canceled that out, that was still originally part of the denominator. So I'm going to include the fact that x can't be positive 1, because that would have made that 0. All right, it's called an excluded value. Again, if you're not telling me this, I'm not going to throw a fit, but it is important to know, because it had get canceled out, it doesn't look like it in our final answer, but x still could not have been positive 1 based on the original problem. All right, let's look at B. So for B, this bottom here factors to x plus 7, x minus 2. So when I look at them, they both have x plus 7. So this is missing the x minus 2, so that will get multiplied over here. But this side wasn't missing anything. There's nothing extra over here to multiply. So this side of my fraction is not going to get multiplied by anything. So it's going to stay x squared minus 5, and then plus my x plus 3 times x minus 2. And the whole thing will be over their common term times whatever things were missing. So just x minus 2 in this case. So we'll multiply or distribute here. So plus x times x is x squared minus 2x plus 3x minus 6. And now we'll combine. We have x squared plus x squared is 2x squared. Negative 2x plus 3x is plus x. Negative 5, negative 6 is negative 11. And the whole thing is going to stay over x plus 7, x minus 2. 2x squared plus x minus 11 will not factor any further, because if I did 2 times negative 11 and got negative 22, no two numbers multiply to negative 22 and add to positive 1, so that's it. We can't factor further. We can't cancel anything else out. All right, so you go ahead and try this one, pause it, and I will show the answer. All right, so on this one, our first denominator factored to x minus 4 times x plus 3, the second to 12 times x minus 4, so x minus 4 was in common. The first fraction got multiplied by 12, the second by x plus 3. So we end up with 17x plus 15 over 12 times x minus 4 times x plus 3. All right, last problem to try together, and then you'll try one on your own. So on this one, both denominators are going to be factored fully. So on this side, multiply to 10, add to 7, we have x plus 5, x plus 2. And on this one, multiply to negative 30, add to negative 1, x minus 6, x plus 5. So they do, in fact, have x plus 5 in common. So that means x plus 2 is going to get multiplied for the second fraction, and x minus 6 will be multiplied for the first fraction. So that's 2x times x minus 6 minus 3 times x plus 2. And the whole thing is over their common x plus 5 times x plus 2 times x minus 6. So let's distribute on top. 2x times x is 2x squared. 2x times negative 6 is minus 12x. Negative 3 times x is negative 3x. And negative 3 times 2 is negative 6. All right, bring over the whole denominator. And if we combine our like terms, we don't have anything for the x squared. So it's going to be 2x squared, negative 12x and negative 3x. We're going to have negative 15x minus 6. All over our entire denominator. If I look at this problem, 2 times negative 6 is negative 12. No two numbers are going to multiply to negative 12 and add to negative 15, so I cannot factor the top. There won't be anything for us to cancel out. And that's our final answer for that one. So you're going to try the very last problem, pause it, and I will show you the answer. All right, so here was our final problem. The first denominator factored to x minus 6 times x minus 2. The second to x plus 7 times x minus 2. They have x minus 2 in common. The first fraction will be multiplied by x plus 7, the second by x minus 6. So when we distribute and combine like terms, we end up with x squared plus 10x minus 18 over x minus 2 times x minus 6 times x plus 7. And that is day 2 of adding and subtracting rational functions.